All right, so let's continue with chapter 3, which was solving systems of equations, and more specifically, we are in section 3.2, which is solving systems of equations in three variables. So let's take a look at this example, which is example 2. And what's interesting about this is that there are definitely three variables here, and there are obviously three equations. But what you can see is that one of the variables is missing in each and every one of these equations, which is actually very convenient for us. It allows us to do this process a lot more efficiently than if we had all three variables in all three equations. So what I'm going to do here is, again, I'm going to sort of pick a variable here, and I'm going to pick x because it has a coefficient of 1. So as far as being like a chameleon, we're going to be able to create a coefficient here as whatever we need it to be. Okay. So I'm going to do something a little bit different with this one. Instead of using elimination, I can see that I'll be able to substitute pretty effectively here. So that's what I'm going to do for this problem. Okay. So I'm going to get x by itself by adding y to both sides. So that will give me x is equal to y plus 6. And then once I do that, what I can do is I can substitute this expression into x in this equation. And again, that doesn't seem like it's going to do much because I'll still have two different variables here. I'll have a y over here and I'll have a z over here. But then I can use elimination with equation number 2, which has y and z. Okay. So I'm going to substitute this expression, y plus 6, into x, and that will give me something that looks like this. So y plus 6 minus 4z is equal to 8. So this will be 3y plus 18 minus 4z is equal to 8. And then subtract 18 to both sides. So you'll get 3y minus 4z is equal to negative 10. Okay. So again, that gives you an equation here of this 3y minus 4z is equal to negative 10, which we will then be able to use elimination to maybe get rid of y or z. I think I'm going to pick y just because, again, the LCM between 2 and 3 is 6 versus the LCM between 5 and 4 is 20. So in my head, in my heart, I feel like the numbers will be smaller, will be more effective for me to do that. Okay, so I'm going to take equation number 2, and I'm going to multiply everything in that equation by negative 3. Right, so I'm going to multiply everything by negative 3 because remember, we want opposite coefficients. We don't want them to both be 6. We want them one to be 6 and one to be negative 6. So I'll just start with the negative 1 first. And what that's going to give me is negative 6y minus 15z is equal to negative 3. Again, multiplying everything in equation number 2 by negative 3 will yield this result. And then what I'm going to do is I'm going to multiply everything in this. I'll call it equation number 4, this brand new equation here. I'm going to take everything in equation number 4 and I'm going to multiply it by 2. And that's going to give me 6y minus 8z is equal to negative 20. And now I have a position where everything is in standard form. I have opposite coefficients on the same variable. When I add these equations, the y's eliminate. And this will give me negative 23z is equal to negative 23. So z is equal to 1. Let's pause this for a second. Okay, so now that we have our variable solved for z, we know that z is equal to 1. We can go ahead and figure out what y is because we have an equation up here with y and z, or here with y and z, or here with y and z. I'll substitute it into the original equation number 2. The numbers are just smaller there, so it just makes sense for me to do that. And then I'll go ahead and solve for y. So this is 2y plus 5 times 1 is equal to 1. So 2y plus 5 is equal to 1. 2y is equal to -4. Y is equal to -2. So we have our second variable out of the three that we're looking for, and we can use this to figure out what x is right here in equation number 1. So I'm going to go back to equation number 1 and substitute my value for for y, which is -2, into equation number 1. So this is going to be x minus -2 is equal to 6. So x plus 2 is equal to 6. X is equal to 4. So there is my third and final piece to this puzzle. And if I write my solution, it will be 4, comma, -2, comma, 1. And there is my ordered triple. Okay. So these next two I'm going to skip just because I said we were going to focus on where we actually get a point of intersection for these three planes. And these are, sorry, this is just more of the same for what we did. And for these guys over here, again, it's the dependent equation with three variables, which we don't really care about. And it's the other one where it's an inconsistent system with three variables. So basically, either everything disappears and you get a true statement, or everything disappears and you get a false statement, and we don't really care about those. Okay, so let's talk about 3.3, which is the applications of systems of linear equations. So basically, word problems associated with three variable systems or two variable systems. So our steps are going to be to read the problem carefully. Obviously, you need to read the problem. We're going to assign a variable, so probably two of them, x and y, or maybe even a third one if we have a third unknown. And then we're going to write the system of equations using both variables, solve the systems of equations, state the answer, and we also need to make sure that it's reasonable. One of the things that drives me crazy in these problems is like, I put out a question and it'll say like, how many child tickets were sold to the play or something like that. If there are two different prices, one's for adults and one's for kids. And students will answer things like -7.3. Well, that obviously doesn't make any sense. You can't sell negative tickets and you can't sell a 0.3 of a ticket to a child. So the answer needs to be reasonable within the context of these application problems. Obviously, if it was just a regular system of equations, then that answer could be fine. But when it's an applied problem, your answer needs to make sense within the context of the problem, okay? And then obviously you can check your answer to make sure that everything is legitimate. All right, so let's take a look here. So we have a rectangular soccer field, has a perimeter of 360 yards, and its length is 20 yards more than its width, and we are going to find its dimensions. Okay, so we're going to go back to our perimeter formula. Perimeter is equal to 2 times the length plus the width. And obviously you have that other one too, which is 2 times the length plus 2 times the width. It's just the 2 distributed in. And it says that the perimeter is 360, so I might as well go ahead and just substitute that in right now while I'm at it. So 2 plus times L plus W. And then it says its length is 20 yards more than its width. So its length is 20 yards more than the width. And once we have this piece of information, we are free to use substitution because we have a variable by itself in one of the equations. We are going to send it to the other equation. So that will give us 360 is equal to 2 parentheses, our 20 plus W plus the original W that was there. So remember, we substituted this part into that. So maybe I'll put it in parentheses so you can see the difference. So this was L, so this used to be L, and this W was originally there, so it needs to stay there. It's not going away because I put in another W, it's still gonna be there. And now we can start to clean this up. So we've got 360 is equal to 2 parentheses, 20 plus 2W, and I'm gonna divide everything by 2 instead of distributing this in. So that's gonna give me 180 is equal to 20 plus 2W. And now I can just do our regular algebra that we learned in chapter 1. So this is pretty sweet. We just start banging this out. we get the width of this soccer field is going to be 80, which means the length, because again, I have this formula over here that says the length is equal to 20 plus whatever our width is. So our length is going to be 100. And you can always check your answer by taking 100. Again, it's perimeter of a rectangular soccer field. So perimeter is adding up all the sides. So a 100 plus 100 plus 80 plus 80 is definitely 360. Okay, so it does check out. Ready? All right, so let's take a look at this one. So it says for the 2013 Major League Baseball and National Football League seasons, based on average ticket prices, 3 baseball tickets and 2 football tickets cost $245.52. And also 2 baseball tickets and 1 football ticket cost $136.50. What were the average ticket prices for the tickets of the 2 sports? Now, if you live around here, obviously you probably do if you're here at CCRI and you've ever been to either Gillette Stadium or Fenway Park, you know that we pay a heck of a lot more than this for our tickets. Even back in 2013, we did. This is probably taken into consider Arizona, which almost pay people to go to their games. All right, at least for baseball. So here we go. So again, we have 3 baseball tickets. So I'll use B for baseball tickets. So baseball tickets is the number of, or the price of baseball tickets, sorry. Price of baseball ticks. And then F is going to be the price of football ticks, okay? And it says 3 baseball tickets, so 3 baseball tickets plus 2 football tickets is equal to $245.52. And then you have this other sentence here that says 2 baseball tickets plus the 1 football ticket is equal to $136.50. So this is perfect for us. It's set up great for elimination because we have standard form. Instead of X's and Y's, we have B's and F's, but no problem. And we'll be able to solve this by multiplying everything in this equation by 2, right? Or -2 in this case, because again, we want opposite coefficients. So if I take everything and multiply it by -2, that's going to give me -4b minus 2f is equal to -$273. Okay, and I know that's a little weird because you have -$273, and I just got over that spiel of saying you can't sell negative tickets. Well, don't worry, things will work itself out, because when you add this equation, this brand new equation here, with this top equation, you end up with this -1b, because +3b plus -4b is -1b, and we end up with a negative value here on the right-hand side. So everything is going to work itself out. So we've got this 245.52. If you subtract that with 273 or $273, you get -227.48. And that means that the average baseball ticket is $27.48 back in 2013, which is fine for us. We were able to figure that out, but we want to know the average ticket price for both sports. So we figured out what the baseball is, and now we just need to figure out what football is. So let's go ahead and substitute that into one of these equations. Maybe I'll pick this guy right here. It just seems easier for us. So we have 2 times 27.48 plus F is equal to $136.50. So we multiply by 2, we get 54.96 plus F is equal to 136.50. And I'm just going to go ahead and subtract the 54.96 from 136.50. And that will give me $81.54. Just double check. So 136.50 minus 54.96, and it's $81.54. Perfect. And again, you could always check your answer by taking these values, this 27.48 and this 81.54, and substituting it into the other equation to see if you still get the valid solution. So let's just quickly do that while we're at it. So 3 times the 27.48 gives you 82.44, and then 2 times the 81.54 gives you $163.08. And if you add those two values together, you get $245.52. So everything checks out exactly the way that it should have, and we are good to go. All right, so a grocer has some $4 per pound coffee and some $8 per pound coffee. She will mix the coffee to make 50 pounds of $5.60 per pound coffee. How many pounds of each should be used? So this is very similar to that other problem that we did back in chapter 1, where it was the candy, I believe it was, that they were mixing it up, and we were trying to get rid of that candy that nobody wanted. So maybe, again, there's some coffee that people don't really enjoy that much, but they really like this one. So if you mix it together, and you can create a value price, and maybe people will actually buy it, and you'll get rid of their coffee. Okay. So again, what we need is a couple of variables. So X is going to be our $4 per pound. So X is our $4 per pound, and it's the number of pounds that we need. And then Y will be our number of pounds for our $8. Okay. And again, we're going to mix it to create this $5.60 per pound coffee. Okay. So again, we are going to take X number of pounds, right, with Y number of pounds, and we are going to make 50 pounds worth of coffee. All right. So X pounds plus Y pounds equals 50 total pounds. That's what they want to, maybe it's an experiment to see if if people like it. So that way, they don't want to make too much and then have to sit on the stuff that nobody wants to buy, and they don't want to sell too little because maybe it's not a large enough sample size. Okay. And then from here, we're going to take our $4. This will be our price equation. So $4 per pound plus $8 per pound is equal to, this one is going to be interesting. What we have to do is take the $5.60, and multiply it by the 50 pounds that we have. So that's going to give us 280. Again, the way that we got this was we took our $5.60 and we multiplied it by the 50 pounds. That's how we got 280. And then we have a couple of equations that set up perfectly for elimination. I'm going to multiply everything in the top equation by -4, and that will give us -4x minus 4y is equal to -200. And our x's will eliminate, hence the name elimination. We've got 4y is equal to 80, so y is equal to 20. So we have 20 pounds of the $8 per pound, which means we need 30 pounds of the $4 per pound, because again, we have 50 total pounds. So if 20 is the $8 per pound, 30 is going to be the $4 per pound. And that's it. So that's how you do these mixture problems. It's a lot easier, I think, when you're allowed to use two variables. Like back in the day, we had to kind of write it with respect to each other. One was X and the other one had some relationship to X, where now that we're able to say, all right, one of our unknowns is X, the other one is Y, I think it's much easier to create these a couple of equations, right? So let's see. This one is pretty interesting. So again, we have a train that travels 600 miles in the same time that a truck travels 520. Find the speed of each vehicle if the train's average speed is 8 miles per hour faster than the trucks. So we are probably going to use the distance formula. Distance equals rate times time, okay? And we have this distance equals rate times time for our, so this will be distance equals rate times time for our truck. And of course, they're both truck and train. So this will be train, I'll have to write it out. And this will be our truck. Be much easier if they said car. So distance equals rate times time for our truck, and this is for our train. I think this was supposed to be an N there. There we go. So our distance for the train is going to be 600 is equal to R times T, and this one is going to be 520 is equal to R times T. And one of the nice things is that the times are exactly the same, right? It says in the same amount of time, okay? It also says that the speed of each, let's see, if the train's average speed is 8 miles per hour faster than the trucks. So what I'm gonna do is I'm going to solve these for T. So I'm gonna divide by R, there we go. And that's gonna give us T is equal to 520 divided by R. And this one's going to be T is equal to 600 divided by R. And again, we've got to be able to write this speed with respect to this R. And we know that it is 8 miles per hour faster than the truck. So at this phase in the game, we can set these times to be equal to each other. So this will be, because again, this time and this time are exactly the same. So you have 600 over R plus 8 is equal to 520 over R. And you know that when you have two fractions set equal to each other, you can take the cross product of these to get 600R is equal to, and I'll do the distribution kind of at the same time, so that way we'll be able to do this with no problem. So we have, what is this? 520R plus 520 times 8. So 520 times 8 is 4,160. And we can subtract 520R to both sides. So we get R on one side. And that's going to give us 80R is equal to 4,160. And then we can divide by 80. So we get the rate is 52 miles per hour. And remember, we set the rate here, this R, to be the rate of the truck. So the truck is going 52 miles per hour, which means the train is going 60 miles per hour. So my train is 60 miles per hour, where the truck is 52 miles per hour. Okay, so while canoeing, and I think this will be second to last one, and then we'll go from there. So while canoeing on the Tickfall River, Shannon traveled 30 miles upstream against the current. So again, that's slowing her down in 5 hours, and it only took her 3 hours paddling downstream with the current back to the spot where she started. Find Shannon's canoeing rate in still water and the rate of the current. Okay, so we can do this. So we know that she is going, again, 30 miles, so that's pretty nice. And we know that she does that in 5 hours. And it only took her 3 hours paddling down the stream, okay? 3 hours to paddle down the stream. So again, we're probably going to use the distance formula. So distance equals rate times time, and distance equals rate times time of going up the river versus going down the river. And we know the distance is the same as 30 miles. One of the things that you need to consider here is that when you're going upstream, your rate is calculated by two things, okay? It's calculated by how fast Shannon is paddling and also how fast the stream is preventing her from going up the stream. It's the rate of that current. So we're going to set X to be Shannon, and we'll set Y to be the current. Okay? So going upstream, Shannon is paddling at X miles per hour, and she is being slowed down by some rate of the current. Versus when she's going down the stream and the current is helping her go faster, her rate here is, again, her same speed that she is able to paddle, plus however fast the current is helping her go down the stream, okay? So we have everything here that we need to be able to do this problem. So this is gonna be 30, because that's the distance, is equal to her rate, which is X minus Y, X minus Y, times the 5 hours it took her to do it, okay? So if we divide both sides by 5, we're gonna get 6 is equal to X minus Y. So there's that equation. Over here, we're gonna have 30 is equal to X plus Y times the 3 hours it took to get back. And if we divide both sides by 3, we get 10 is equal to X plus Y. Well, this is beautiful for us because we now have two equations in standard form. Two equations in standard form. So I don't know what happened there. Things are going wild. So we can use elimination to do that. As a matter of fact, we already have opposite coefficients. So we have 6 is equal to X minus Y. We have 10 is equal to X plus Y. We can add these equations together to get 16 is equal to 2X. Again, the Y's eliminate. X is equal to 8. So it appears that Shannon is able to paddle at 8 miles per hour, which means the current is going at a constant rate, average rate of 2 miles per hour. So Y is going to be 2 miles per hour. Okay? So that is it for chapter 3. Actually, you know what? There's this one over here. I'm worried that I'm not going to have enough space to actually do this problem, but we'll figure it out. We'll try. So an apartment store has display features 3 kinds of perfume: Felice, Vivid, and Joy. And there are 10 more bottles of Felice than Vivid. There are 3 fewer bottles of Joy than Vivid. Each bottle of Felice costs $8, Vivid costs $15, and Joy costs $32. These are the craziest names of perfume that I've ever heard. The total value of all of the perfume is $589. How many bottles of each are there? Okay. So the first thing I want to do is assign some variables. So I'll set X to be the number of Felice. I don't know. It doesn't really matter. Oh, come on. This thing keeps going crazy on me. So once I read these again, let's just think about this. What happened to what I just wrote? Go on. So there are 10 more bottles of Felice than Vivid. So maybe I'll set Vivid to be my X. So X is going to be Vivid. So that means that Y is going to be Felice. And then Z will be the other one, which is Joy. Okay, so I'm just defining my variables over here. So there are 10 more bottles of Felice than Vivid. Okay, so that means that there's going to be an equation, Y, which is Felice, is equal to 10 plus X, because again, there are 10 more bottles of Felice than Vivid. So you take whatever the Vivid is, add 10 to it, that will give you the number of Felice. Okay. There are 3 fewer bottles of Joy than Vivid. Okay. So this one says Joy is going to be equal to however many bottles of Vivid you have, take away 3. That's what that equation says. Okay. So we've got 2 equations so far. And then we have a cost equation. So we have $8 for Felice. So we have 15 bottles, $15 for Vivid. Just making sure that my order is matching up here. $8 for Felice plus the $32 for Joy is going to be equal to 580. I don't know what is going on right now. $89. Okay. Should have just quit while I was ahead. So here are my equations, all right? And this is great for us because we can use substitution. We can substitute this and this in for their respective variables, and that will give us a big, long, singular equation with just x's in it. So let's see what that's gonna look like. So 15x plus 8 times, again, substitute this in, 10 plus x plus 32 times, substitute this one in, x minus 3 is equal to 589. So 15x plus 80 plus 8x plus 32x minus 96 is equal to 589. So let's start to combine all of our like terms. So this is going to be 40x, so that's 55x minus 16 is equal to 589. And now I can start to solve this equation. So adding 16 to both sides, we've got 55x is equal to, I think my pen here has had it for today. So 589 plus 16 is going to give us 589 plus 16 is 605. So 605, and when you divide 605 by 55, you get 11. So there are 11 bottles of this Vivid, okay? And now that we know that there are 11 bottles of Vivid, we can do the rest of these problems. So that means that Y, which is the Felice, there will be 21 of those bottles. And last but not least, we'll be able to figure out that there are 8 bottles of Joy, okay? Because again, 11 bottles minus 3 will be 8. So what started off as being a pretty difficult problem, I think I had more technical difficulties than actual difficulties of doing the problem. But yeah, so we've got 11 bottles of Vivid, 21 bottles of Felice, and 7 bottles of Joy. And I'm glad that I get to stop saying those ridiculous terms. So thanks very much for listening. That's the end of this video, and I will hope to see you all on Wednesday for any questions, or possibly even, actually it will be Wednesday regardless, because Monday there's no class because of Memorial Day. All right, thanks for listening.